So one of the things I've been extremely interested in for the last 30-something years wasn't just the idea of AR and VR, although I've done a lot in terms of just building simple applications, building head mounts. I still am designing some new head mounts that should be coming out later this year. But the challenge to me isn't just that, here's these new hardware devices. In fact, they're the least interesting aspect of the whole thing. What's really exciting about it is that we're at a transition stage where all the old systems that people have created will no longer scale to this next generation. They won't work. People are going to try to get them to fit. You're going to try to get Android to be kind of a foundation for AR, trying to get Windows to be a foundation for AR and VR, but their fundamental shift in many, many dimensions, and not just the user interface or the way you display it. I see AR and VR as fundamentally a collaborative and communication platform. And so we need to start thinking in terms of how we use these systems to share ideas and expand on the nature of how we engage with each other. So one of my good friends and collaborators over the last about 20 years actually is Alan Kay. This quote he gave, it's in a paper called A Personal Computer for Children of All Ages, where he described the world that we live in today. He came up with this idea called the Dynabook, and that was the thing that really defined what Xerox PARC was after. They called the Xerox Alto the interim Dynabook. And I'm going to show you a picture that he drew. This was he literally drew this. That paper I was talking about, Personal Computer for Children of All Ages, described that device. And what's really fundamentally interesting about it is if you look closely at the two screens that the kids are working with, they're actually programming Space War. They're collaborating. They're literally sharing the screen, and they're not just playing games, but they're programming those games. And part of this quote was actually in that paper. By the way, Alan's known as the father of the personal computer, and this, I believe, is the first place that term actually appeared. And man is much more than a tool builder. He's an inventor of universes. And our big challenge in AR, VR isn't just creating a cool experience, but liberating that experience in a very fundamental way, which is, today we look at it as we look at your iPhone, for example. You can't really program that. You can't create on that. And my expectation is, for the most part, it's going to be very, very difficult to create in VR and AR. Because not just because the tools aren't there, but because there's a lot of pressure not to allow people to do that. You get control of content, and you kind of control your customers. And so one of the things we're really interested in is how do we avoid that problem. And so we're building a platform. I call it Croquet 5, as like there, to allow people to create, share, and experience without ever having to leave the 3D space. And so I'm going to give you kind of a quick tour of an update of the system. It's been evolving over the last year, and it actually has some pretty neat capabilities. So let me just walk through this. One of the important things to me was just this ability to visualize very, very large data sets. This is one I did a while ago, which is basically a 3D model of the US. You can sort of see the terrain there. And it's a pretty high definition image. And obviously, it's a true 3D model. I can kind of see that. And that's a simple one, of course. But we want it a little bit more complex. And so it is pretty clear that spreadsheets inside of a space like this offer a very, very different kind of experience. So this is sort of the standard spreadsheet I've been showing. This is a mortality data space that is basically U.S. males from 1900 to 2010, and each of these values is the probability of dying that year. And this is up-to-date data. So what I can do here is literally, the red is bad, by the way. We're looking at a table that shows the probability of dying in every single year for every age. So year is up and down, age is left, right. And so I literally can drag this around like that, and I can change the spread, get a sense of that. And I find this really interesting to me because this is a spreadsheet of literally 110 rows and 110 columns. And you're literally seeing this kind of heat map, which is really kind of a wonderful way to look at things. Now, there's this really interesting line here that happened. This is 1918, this line here. I thought it was an error for a long, long time. And then somebody pointed out to me, this is Spanish flu. And I'm going to switch real quick to this. Spanish flu, is people don't know about this, but in 1918, during kind of ending World War I, 50 to 100 million people died that year from Spanish flu, which is just extraordinary. And it's right here. It's just this red band that obviously gets buried out there because people are older, but it just wiped out between 5 and 10% of the world's population, which is just an astonishing thing to me. So I'm going to kind of walk through a little bit here and give you a couple of charts. So this is infant mortality, right? And what we're looking at is in the year 1900, infant mortality was 14.5%. Basically, 1 out of 7 children died. And I kind of showed you a little bit of out the sort of the World War I time period, which was, this is the Spanish flu again. But what you see here is literally the cost of World War I and mortality rate for 20-year-olds. And then here's World War II. And then we have basically the Vietnam conflict. And then I come out here to a little bit further out, say 64. And this is an interesting one to me too, because what you're seeing here is kind of a flat line. And, oh, hold on. I want to see if I can change this around, so I want to have it just right. And there we go. So it's kind of flat. You can sort of see a slight up and down. But basically in the 70s, we saw an incredibly steep decline in mortality rate. This is 80-year-olds. And obviously health improved significantly, but I think more importantly, cigarette smoking was curtailed. Here's another chart, a good deal larger. This is every country on the planet and their relative wealth. It's actually sorted by modern wealth at the bottom. So this is basically 200 years of data. And I'm going to just plot this like here. You can kind of see literally going across this data set. United States is, I think it's this bar right here, yeah. And who's the wealthiest country right now? Qatar. Although back then it wasn't pretty. Back in the this is from 1800. So, Interestingly enough, almost every country in the world was a third world country. By the way, this data can be plotted in a different way. And state of the world. And this is the same data plus some others. And I just thought it'd be fun to plot that this way. And what you'll see here is a lot of weird, I think a lot of these are just bad data outliers of various sorts. But I thought that of the other spreadsheet as well. So these might actually be just fine. But I find it really fascinating and very satisfying to sort of fly through this really, really super large data set. So that's kind of a traditional view of information in a space like this. One of the things we're really excited about and what the next platform should really be focusing on is obviously collaboration, as I said earlier, but I think particularly what we're after is we have access to supercomputers not just in our PCs, but on our phones with GPUs. So we're looking at 300,000 particles running here, allowing us to visualize an actual simulation. This is live. It's not like a video. It's actually being computed. And with any luck, I can change this code a little bit. So I'm going to, oops. Let me actually, before I do that, because I probably messed it up. Is that it? I want gravity. I don't have the code. I'll screw with it later. Anyway, the point is this is totally editable when it's working right. And I'll show you another one that's pretty cool. This one is an actual hurricane with 1 million particles running. Now, you can actually do that if you know a language like GLSL, which is sort of an assembly language for graphics chips. What we wanted to do is have a language that middle school, high school kids could use. And so we've been working on a new way of describing how to program these very, very large simulations. So this is running live inside the system, and this is the actual code that runs it. And I'm going to run through another one. This one is an experiment that Alan asked us to do. And what you're looking at is a shell of particles. And there's an interesting fact about in physics that if you have a spherical shell and it's empty on the inside, the gravitational force within that shell is zero in the entire space inside. And so we actually, and of course, if it's outside, it's it's treated as a point mass. And so we have this little particle that's kind of doing, you can kind of see it there, orbiting our little planet. And what I can do is, let's see, this is my little turtle, and this is the pieces of the shell. And what I'm going to do is set him to be instead right in the center, 255, and I'm going to get rid of that. Actually, I'm going to pull him off to the side, because it's actually doing the full computation. Make that 40 or something like that. And then when I recompile this, oops, I didn't want to do that. Should be here. There we go. Now that particle's inside, and there's no force moving it anywhere. I can put it anywhere inside the shell. And this is just running the simulation where each particle is pulling to each other particle. And so basically you see this really interesting ability to start playing with physical models. I find that just fascinating, and the fact that we're literally dealing with 1 million particles in this case, and treating it as nothing. And the thing isn't just that you can do it, but the fact that we can describe that simulation very tersely in a way that school kids can understand and play with is really key. And further, this is all going to be collaborative. So we'll be able to share these experiences. I'll be able to design this, and you and I can explore what that means. Now, you can see that this is kind of our work in progress. We're adding a lot of functionality, a lot of capabilities to this as we go along. One of the things we just added was integration with Google's Poly. And so what we have here is I'm just doing a search on their database. I'm going to just grab something fun. This one's pretty cool. And hopefully it'll load. There it is. So what you're seeing here is a tilt brush model that somebody had built. Ooh. And I find this really gorgeous. And it's just accessible. And now one of the things we want to be able to do, obviously, since it's in my space, we can start programming it, integrating it with the rest of the system, and just placing it wherever we like. So we're looking at full integration with the outside world, of course. And by the way, this is, you can probably see, I'm running inside of a browser. This is a WebGL application, or WebVR. And so everything I'm doing runs on every single device that supports browsers today. And I'm going to show you one more quick thing. The roots of this system come from a system called Smalltalk. This is all written in JavaScript. But Smalltalk was the system that was used to define the user interfaces, and really it was the language that really invented, I think, more than anything, the idea of objects and object-oriented programming. And this was also developed at Xerox PARC. And this was coded by a guy named Dan Ingalls, who's kind of the co-creator of Smalltalk, maybe in some ways more than Alan Kay. But what you're looking at is a system that is 40 years old this year. And we didn't just port the code. We wrote an emulator for the Alto. So what you're looking at literally is that big computer that Xerox had is running as emulated in JavaScript, which is then pasted onto a texture, which is then put into our 3D space. And we've got the same capability. Now, the reason that's interesting is because they use that system, that Smalltalk was used to build Smalltalk. It was used to build the interface that we all know and love. Overlapping windows was invented as part of that. Pop-up menus was invented as part of that. And the reason they could do that was because the system was written in itself and they could modify it at every level. And we're doing the same. So every bit of code that I've been showing you is right here. Accessible and available and programmable within the system. So this is the actual the code that drives this window system that I'm showing you. So you can actually see how I did the rotation. It's right here somewhere. This is the buttons, and I can actually change that button if I wanted to. Every bit of the system is in the system, which means that we're now able to modify it while we're using it and extend it while we're using it. And I think that's the real necessary thing, because here's the problem with VR and AR is we don't know what that interface should be. We have some ideas, and we're trying to do the ship in the bottle. We'll design it, and then we'll go inside and try it. But the reality is we're not going to be able to make any progress until we spend all of our time inside of VR, AR, and we build the system as it's floating. In other words, instead of doing a ship in the bottle, we're going to have to get on the boat and launch it, and then as it moves, we're going to extend it and enhance it. So, and my opinion, and we've been doing this for a long time, there's no other way to really create what VR and AR are supposed to be. We have to build a system that allows us to build a better system. Doug Engelbart had that concept of bootstrapping, where the technologies allow us to build tools that then advance our technologies, which allow us to build better tools. So we're just on the threshold of being able to make that transition from outside the world into inside the world, and then having no limits within it once we're there. And that's the most exciting thing to me of all, is that this indeed is a new platform. And it's a huge new opportunity, because whatever you think VR and AR is today, you're wrong. It hasn't really been invented yet. We're playing with the veneer of that technology, of that system. Once you consider the idea of collaboration, once you consider the idea of massive computation, and of course the visualization, and the ability to dynamically modify that with your team, with your friends, it's going to be a totally new thing. And that's by far the most interesting thing to me here is we are inventing the future as we talk. So I appreciate that. By the way, one other thing I should mention about this, since it runs on a browser, it also runs on a phone. And so one of the things we're particularly excited about is very, very low cost, very powerful systems that are very accessible anywhere in the world. Obviously, we're looking at billions and billions of phones. A lot of people are getting phones before they get indoor plumbing. What's that mean? That means if we can give them a platform like this that fully enables them to not just be consumers of information like you usually think of a phone, but actually full creators and fully empowered web developers in a sense, I think that's a big transition and a very important one. So thank you very much.